Okay, class, I'm back and welcome to our fifth week of uh, physics. So today you may be wondering what happened to the exam. And what happened to the exam was several things. First, I was unable to get it in a format to put it on Blackboard. So my next option was to give it to you as a take-home exam. The only reason why I didn't send it out to you as a take-home exam Friday, Saturday, or Sunday is because I needed to limit the time that you had to turn it in. And I didn't want to interfere with your weekend because some of you it was Father's Day weekend. I didn't want to put that kind of undue pressure on you. So I thought I would wait until we got together again to tell you that I was going to give you a take-home exam and that it will be due before class on Tuesday. So now that you know that you have a take-home exam, hopefully you can arrange your next 24 hours or next 20 hours to have time to work on it. You still will have more time than what I want you to have to work on it, but still, that's the best I can do. So in the meantime, though, since I haven't given the exam yet, I want to do just a review today. So I'm going to pull up my screen and share my exam with you. This is actually the exact thing that we reviewed on Thursday, but this time I want you to work it out and give me the answers. I need each of you to go now and get paper, calculator, pencil, because I will be grading this as a part of my assessment, and you have to give me your answers in private. And there are only a few questions, the exact same ones we had before, but now you have to work them out. So I'll give you a few minutes to go and get paper, calculator, and pencil. So go do that now. Okay, so everyone should have paper and pencil. I'm going to go now and we're going to pull up the quiz. Okay, number one, a person 5 feet 8 inches tall is approximately how tall in SI units? So work on that problem, please, and give me your answer. Put your answer in private. Okay, I only see two answers, but I'm getting ready to move on to the next question. Let me see what the answers are. I don't know why my chat's not showing up. Hold on. Okay. Nigel and Alex have given me answers, but let me look at mine. Let me look at mine once more because I don't have the same answer that you all have. Well, we'll just do it together, okay? Once we go through this, now the rest of you that did not respond, I'm saving this as my grade, where I'm going to grade your work. So you should have put in something. The others of you who are here. Okay, okay, Kirsten, I like that answer. Very good. Okay, so I see one answer that I think is the correct answer, but before I say anything, let's just work the problem out together. Okay, first of all, let me see what you did before I do anything. Let's see, I'm not gonna go with Kirsten. Let me see who else I have here. For some reason, my chat is not showing up. I can't see who's chatting. Okay, let me hear from Nigel. Nigel, do you mind telling me what you did to solve this problem? What did you do to solve this problem?
So what I did is I divided the 5 foot and 8 inches by 3.281 feet.
So how did you write the 5 feet 8 inches? What did you actually divide by 3.281? What?
I put 5.8. I think that's what's supposed to be.
Well, think about it right now. Think about that. 5 feet 8 inches isn't the same as 5.8, right?
Right.
So what should you have done first with those 8 inches, or either that 5 feet?
Converted both into meters separately and added them.
That's a little long. Okay, that's a little long. You can do that. I wouldn't advise that. Anyone else have a suggestion for Alex?
Well, turn them all in. Oh, go ahead.
What I did was, since 0.8 is, and there's 12 inches in a foot, so 0.8 is 2/3 of 1 foot. So I just divided 2 over 3 and got the 0.666 succeeding, and so that'd be 5.6 divided by the 3.2.
Okay, very good, very good. Okay, Keston, what did you do, Keston? I don't think Keston wants to answer the question. Okay, but I see that Monier. Okay, now Alex has a better answer. That's good. That's good. Okay.
Because my mistake was, at first I just didn't think about it, and I was thinking 3/4 of an inch. So I put 5.75, and that's why I got that. And then I realized it was 2/3 of an inch. So.
Okay, very good, very good. So once you see your error, then you won't make that same error again, because now you understand completely what the author or what the problem is asking for. Okay, very good. Let's go to number 14. What volume, I should say, okay, let me say, this is in cubic meters. Let me put this in here, please. Hold on. I left that off. What volume in cubic feet is equivalent to? Okay, what volume in cubic? Can you all see what I'm typing here?
Yes.
Okay, good. All right, so I want this volume to be in cubic feet is equivalent to 5 meters cubed. What volume is that? Okay, I don't have any answers yet. No one? No one has an answer? What volume in cubic feet is equivalent to 5 cubic meters? What volume in cubic feet?
I put an answer.
You did? Okay, let me see what you have. Okay, very good. Nigel, no, no, Keston. You have cubic feet. I'm looking at, okay, I'm looking at the units. I'm not giving anybody full credit yet because I'm looking at the units. I'm looking at Nigel's units. I'm looking at Alexis' units. Keston has the right units. Monye doesn't have any units. So I want to see if you're going to, but overall, this is good overall, but I want you to have it perfectly correct. Perfectly correct. Okay. All right. Let's see. Okay. Very good, Alex. Lex, that's better. Okay. Okay. All right. Oh, I can't see the screen. Let me go back to share the screen again. Thank you. Let me share the screen. Okay, stop sharing. And let me try to share the screen again. Okay. Kaylin, can you see the screen now?
Yes, ma'am.
Okay, great. All right. So here, of course, what you're doing is you have 5 cubic meters. So your area is in cubic meters. But you know that 1 meter is 3.281 feet. So 1 cubic meter would be 3.281 cubed. So you have to cube that 3.281 and then multiply that by 5. And that's what I see you all have done for those of you who got it correct. So that's good. Okay, let's go down to number 5. I need for everyone to be working now because that way, let me go back up. Are there any questions on the first 2 problems? For those of you who are in this session now, don't be shy about asking questions because that's how you're going to learn.
Can we just do number 1?
Number 1, okay. Let me go back and let me grab my pen so I can do it on this page. Let me grab my pen. Give me 1 minute. Okay, So the way that I solved the problem, class, is I said, well, 5 feet, 5 times 12 is 60. So that's 60 plus 8. So I just said 68 inches. So I began by saying 68 inches because I like working with whole numbers as much as possible. So then I said, okay, it takes 12 inches to equal 1 foot, and it takes 3.281 feet to equal 1 meter. So in my head, though, because I have to even write this down, in my head, I just divided 68 by 12 and then by 3.281. And that gave me my answer. So that's what I did. Now, let me see if you can do this problem. Okay. Let me change this problem quickly. Just because we're on this topic, let me just change this problem quickly and see what you're going to do with it. Hold on. Okay, now I have this person. A person is 1.8 meters tall, is approximately how many feet, how many inches? Let's solve that problem. This will allow me to know that you really understand this problem. Okay, so you're given a person, he's 1.85 meters tall. What is his height in feet and inches? Okay, I got an answer. Okay. Okay. So far, the answers I see from everyone's incorrect. Incorrect so far. So far, incorrect. I don't see the right answer yet, but I'm glad that you all are working on it. You're doing the right thing. Okay. Okay. Well, Keston, won't you turn your answer into the answer I asked you for? How many feet? How many inches? Like you said, a person is 5. Okay. No, Alex, you're getting close though. This person is 1.85 meters tall. How many feet and how many inches?
But I feel like it's Isn't it less than 1 inch though?
Okay, so let me just see if we can go through it together. Okay, so let me go back to annotate. Okay, so you have 1.85 meters. So we know, hold on. We have 1.85 meters. And we know that 1 meter is 3.281 feet. Okay. So that's where I think you ought to get in the first answer, which I agree with. 1.85 times 3.281. And you should have gotten 6.069. Okay. And this is what? This is feet. Right? Now that's correct. But I want the answer to be in feet and inches. So you know you have 6 feet. But that means that this part of the answer needs to be converted into inches. So you say, okay, well, I have 0.069 feet. But how many inches is that? Well, we know that it takes what? 12 inches to be 1 foot.
So we're dividing by 12, not multiplying.
Right.
Oh, okay. That was my problem.
You're converting these inches now, these feet now into so many what? Inches. So when you take that and multiply that by the 12, you get 0.83. So we're going to say this person is 6 feet, 8 inches. You see that? Okay.
Wait, so I'm sorry, I'm still confused because I thought it was like saying that it's like almost not even 1 inch, like 6.00 something inches.
Right, but 0.069 is a part of a foot, right?
Okay,
He's
yes.
6 feet, 0.069 feet. So the 0.069 feet, I want to convert that into inches because when we give someone's height, we usually say they are so many feet, so many inches. We don't say, oh, he's 6.069 feet. We don't say that. A basketball player, we give his height. He's pretty tall for sure, but we don't give his height in point so many feet. We say he's 6 feet, 8 inches. Right? That's how we give our height here in the US.
Okay.
Okay. Does anyone else have a question about this problem?
Question, so you multiplied the 12 or you divided? Because I didn't get 8 inches.
Okay, you got 0.069 times 12. You should get 0.838. But now this is what? This is in inches.
Okay.
Oh, I'm sorry. I see my error. Hold on. Let me make
You
sure.
see, yeah.
Yeah,
Okay.
I did 0.69 on my calculator. I didn't do the 0.0. Okay, I'm sorry. Okay, that's what I did. I didn't put in the point. I put in the 0. I put in 0.69. That's where I got that from. Okay, so now I see what you're saying. So now let me take this off. Let me get my eraser. Hold on. Yeah, I put in the wrong number in my calculator. Okay, here we go. So now what do we
Yeah,
have?
I was just wondering like how it was almost like 6 feet, 8 inches. That's almost 7 feet when it was 6.0 something feet.
Right. That's because I put right in my calculator, I didn't put the 0 there. Okay, so now I have it correct. Okay, now we have what? Let me do it again. Okay, 0.069. Oh, 0.069 times my 12, right? And that gives me what? That gives me 0.8, right? So someone said 0.83 inches. Okay, that's what I have. Okay, Nigel, did Keston say that? Nigel said 1 inch. So, okay, so we're gonna round it up to 1. That's very good. Okay, let me get my thing. Where's my? Okay, I'm gonna round it up to what? To 1. Okay.
So should we be rounding these then? Like if
Well,
it's
because we don't, normally when we have the, and this is a good question. Normally when we give a person's height, sometimes people will say, I am 5 feet and what would they say? 6 inches, 7 inches, 8 inches. Don't they normally say it like that?
Yeah.
But they're not probably exactly that. So since I want you to give it to me in inches, you're saying what I want you to say, I'm 6 feet and 0.83 inches. Is that what you're asking me?
Yes.
Okay. Well, we probably want to go to the nearest whole inch.
Okay.
Okay. All right. So I'm glad we did that problem again so we could see about doing that. Okay. Let's take one more very quickly. Let's see who's going to be the first one to, now that we got it down packed, let's see who's going to be the first one to get this one. So now we have someone, this is going to be a tall person, but that's okay. Okay. It's going to be a tall person. I'm going to say he's 2.02 meters tall. Okay. Let's take this person. Let's see what his height is in feet and inches. Okay. This person is 2.02 meters tall. Let's see how tall he is. Okay, very good. I see an answer from Alex. Okay. I think Lex is getting it. Let's see if others are getting it. Let me see a few answers before I move on. Okay. Okay, Monnier, that's good. Monnier, that's good. Mhm.
Hello?
Yes, I'm listening.
Are you getting my answers?
Let's see, what's your name?
Kaylin?
I see your answer, Kaylin, but I didn't give you credit for that one because your inches are not correct.
The one that we just went over?
The one that we're doing now, he's 2.02 meters tall. Okay, I'm looking at Monnier. Okay, Nigel, that looks good. Oh, Nigel, that's okay, that's inches. Okay. Okay, Nigel,
Yeah, I meant inches, sorry.
yeah, but don't you want to round that up since it's
Yeah,
okay. You can round it up. I wouldn't truncate it to just 7. Hey, that
okay,
tall football player wouldn't want to be a whole inch shorter. He wouldn't mind being a whole inch taller. Okay. Lanisha, that looks good. Nigel, that looks good. I'm still waiting on Keston. I don't see Keston's answer. Okay, but you all are getting the point. So when I have this problem on the exam, I will know that you know how to do it. Not that you just looked it up in your calculator, that you know how to solve it. Okay, number 14, I think everyone understood that one. Let's move to number 5. These are just problems I took from somewhere. That's why the numbers are the way they are. Okay, so the inches, Kaylin, is 6 feet 8 inches. Because when you got that 0.627 feet, you convert that into inches and you would get 7.5 inches. Let me answer my phone real quick because someone keeps calling me. Okay. All right. Okay, Keston, that's a good answer. What's the inches? The inches is 8 inches. Okay. So work that out again on your own, and the answer should be 6 feet 8 inches. Make sure you get that. Let's move on to number 5 because we got several more to do. Okay, number 5. A car is initially traveling. Let me put one more word in here, just to make this a little bit more challenging. Okay. North. at 72 miles per hour. The brakes are applied and the car stops over a distance of 25 meters. Ooh, let me see. Let me give it a little bit longer just in case I don't have a good number here. Let's just go with 45 meters. Okay. Now, what's the car's acceleration while it was braking? Okay, so let's solve this problem together. What are you going to do first?
Change miles per hour to kilometers per hour.
Kilometers or what
Or
about,
meters.
okay, what about just what? Meters per what?
Second.
Meters per
Yeah,
second.
meters per
Okay.
second.
First thing you got to do is convert that. Okay, let's do that first. Okay, so someone give me my initial speed first. Before we go any further, let's make sure we have the initial speed correct. Okay, let's see what somebody has here. Okay, very good. Okay. All right. Since I have 3 sig figs, Nigel used 3 sig figs for his initial speed. Use 3 sig figs for that.
Okay.
That way our answers would be more accurate. Okay. Okay, so now we have, once you find, so did anyone have difficulty converting miles per hour? Okay, very good, Keston, very good. Okay, so that means we have to be able to convert that quickly. See, that's only a part of the problem. The entire problem requires a few more steps. So that first step has to be done quickly. So now you know what to do. If it's in miles per hour, what do? Multiply by 1.609 and divide by 3.6. Once you do it enough times, you're going to remember to do that. If not, just write it down quickly. Okay, so now you have your initial speed. So now you should be starting with your initial speed, and we're going to say 32 point, oops, I'm writing the wrong thing first. Oh. My initial speed, I'm going to say, is 32.2 meters per second. Okay, the brakes are applied and the car comes to a stop. So my final speed is going to be 0. Okay. All right. Move this. And it comes to a stop over a distance. So my X then is 45 meters. So now, what am I looking for? I'm looking for the acceleration. Okay, so solve for the acceleration. Okay, I see one answer. Let me see if I can see a few more answers. Okay, let me see what answer I have here. Okay, of course, I'm looking at Nigel, and I'm looking at the units, Nigel, and there's something else that I want you to look at. That's why I put the word north. I put the word north here for a reason. Okay, let's see what someone else is saying. Okay, Lex, that looks good. One more thing I want you to do, Lex, and I want to know if the others have questions before I even answer your question, before I even make a correction on Lex. Does anyone have a question before I move? I see two answers. So I want to know if the others of you, when you see this, do you think of your kinematic equations? The one that should come to mind is V final squared is V initial squared plus 2AX. And immediately, you should be able to say that A is equal to 0 minus V initial squared over 2X. You should be able to move to that step quickly now because you're in college. You don't have to be going through the elementary steps. Once you see this problem and you're looking for A, you should immediately be able to do this. Therefore, when you solve this, A is going to be negative. Take that number that we have here, square it, divide it by 2, divide it by 45, get that answer. So what is the car's acceleration while it's braking? You should say 11.5 meters per second squared, comma, south. And why is it south? Because the answer you would get is negative. The acceleration is in the southern direction, due south. So that's the kind of answer that I'm looking for. Okay, that's why I put the word north there, so they give you a clue as to the acceleration while braking, because that means you understand that the car is trying to move forward at 72 miles per hour, but something is slowing it down, acting against it. Okay. All right, let's see what answers I have now. Okay, Kaylin, is it supposed to be negative? Okay. All right, now let's go back through solving the equation again. Let me just clear this again. Okay, so already we have found out that 72 miles per hour, the initial speed, is 32.2 meters per second. We found that out. The final speed we know is 0, and it stops over a distance of 45 meters. And we're looking for the acceleration. So again, the equation that comes to mind, because we don't have time, okay, and that's why when you're doing the exam between now and tomorrow, you're going to have your equation quiz sheet in front of you so that you can quickly recognize that the one you're going to use says V final squared is V initial squared plus 2AX. So your goal is to get this A by itself. So that means then that the first thing you're going to do is get rid of the term that is being added or subtracted. So that means that on both sides of my equation, I'm going to subtract V initial squared. When I subtract it over here, it's gone, which really means it moves to the other side and it's just negative. V final squared minus V initial squared. That's what it actually means. I'm subtracting that from both sides. I want to get this term by itself, 2AX. In other words, when this term goes over here, it's negative over here. So now I want to get A by itself. So that means I'm going to divide this side of the equation by what I am multiplying A by. So that means then that A is going to be, in this case, V final squared is 0. So I'm going to say 0 minus V initial squared over 2x. So you see, once I get it like this, I don't even have to put all this on my paper. Now I go to my calculator and I just say whatever I have in my calculator, because this is already in my calculator from when I solved for this speed in meters per second. So it's already there. So I simply square it. Then I divide it by 2, and I divide it by 45. That's the best way to solve these problems, all in one step in your calculator on your exam. Okay, I hope that answered your question. Now, in number 18, a very similar problem. But this time, let me put some space in here. A very similar problem, but this time, the wheels of an automobile are locked as it slides to a stop from an initial speed of this. So now what's happening? Oops. Okay. My initial speed is 35 meters per second. It comes to a stop, V final. 0. If the coefficient of kinetic friction is given, so this is my mu sub k, and the road is horizontal, approximately how long does it take the car to stop? So now I'm looking for time. In order to find the time, I need to know what equation, which of my kinematic equations I can use to find the time. Now, distance is not given, although I could solve for distance if I had enough information. But the information that I do have, see, we're in chapter 4 now. So now I'm looking at this problem from the viewpoint of what is the force that's causing this to come to a stop. And so because I've just done this other problem, I know that the car wants to move forward, but there's a force that's acting backwards, acting against it, opposing, I should say. And that force now we know is what? The frictional force. So the frictional force, the object is moving forward. So according to Newton's law, an object is changing its speed over time. That means the object has acceleration, or in this case, deceleration. So the car wants to move forward. So we know that that force that's pushing it forward is being opposed by a force that's acting in opposition to it. That's what that problem is telling us. So we say, okay, now some of my forces then, the car wants to move forward. That's the mass times acceleration, is being opposed by, acting in the other direction, this force is being opposed by the frictional force, and that's F sub k. And F sub k, we know the equation for that is mu sub k F of n. And do you remember what F of n is? F of n is just the normal force. In this case now, and this is why you may want to draw a free body diagram still, because this car has weight, okay, that's mg. It has a perpendicular force. The perpendicular force we said is F of n. The car wants to move forward, that's ma, but it's being opposed by F sub k. Those are all the forces that are acting. So once you draw this picture, you should be able to see that F of n is just mg. So now I'm going to solve this equation. ma is equal to mu sub k mg. Now, the m's will cancel out. So my acceleration is equal to mu sub k times g. Now, the question is, what number am I going to put here? Am I going to put a negative g or positive g? Well, the question is, what is f of n? This f of n now is just this f of n you see is always a positive number. So you can just think of it like that, because this number is always acting upward. This value is acting downward. So that's one way to look at it. Okay. So now you say, well, that's true. When I solve for this number, I'm going to get a positive number. But what did this acceleration do? Just like in the problem before it, what did it actually do? It slowed the object down, which means then that it has to be deceleration. Now, why is that important? Because once I find the value for my acceleration, let me, it's getting kind of crowded in here. Let me just put a spot right here, okay? Let's find the acceleration. So I've got mu sub k, which is 0.55 times 9.8, okay? So when I do 0.55 times 9.8, I get 5.39. Now watch this, 5.39 meters per second square. This unit right here. Now, which equation am I going to use? Well, I know acceleration, I know v final, I know v initial. I'm looking for time. So my equation says acceleration is change in speed over time, which is, I'm looking for time now. So that means this implies that time is going to be change in speed divided by acceleration. T goes up here, A comes down here. Okay, what's change in speed? Change in speed is v final minus v initial over acceleration. So what's going to happen? If I put in v final as 0, and I subtract 35 meters per second and divide that by 5.39 meters per second square. Meters and meters are canceled. One of these cancel one of those. Then when I do that math, I'm going to get 35 divided by 5.39. And when I look at this, I'm going to have negative 6.49. Now, I'm looking for time. Time can never, ever, ever be negative. Time can never be negative, class. And therefore, this question requires you to understand what is meant by deceleration. In other words, in order for the object to come to a stop, this number had to be negative. The same way when we solved for the number up here, we said it was south because it had to be pointing in the other direction. So therefore, this number, even though I don't have it here, this number is what? Is negative. Even though when I solved for it over here, I'm sorry, up here, this G is actually the magnitude. This number is pointing down, this one number is pointing up. This is clearly a positive number. However, it's the acceleration that brought it to a stop. So I want you to think about that when you're solving the problem. And again, I'll say this. Even if you solve the problem and get a negative number here, at least you know that time is a scalar and time cannot be negative. So when you solve the problem all the way correctly, but it comes out negative, think, I know that time can't be negative, mass can't be negative. Those are numbers that just can't be negative. So I just assume that it's a positive number and move on. Okay. Any questions on that problem? Okay. Let's go to this problem. Okay. This is the problem we went over last time as well. So we know that her mass is the same, but now we have a child. I meant to put this right here. Let me put this a little, let me put a little further out. Let me just, let's put it way out. Let's just put it at 4 Earth radii, okay? Now, what is this child's weight, okay? Let's see who can give me that answer quickly, because I told you how to solve it. In other words, if you're taking the ACT or MCAT or the exam to become registered for physical therapy, you want to solve it the quickest way you can solve it. So let me see if you can just solve the problem knowing intuitively what the answer is. If you remember, if you studied for the test, you should know what to do for this answer. I got one answer. Let me see what that is. Okay, I got my answer. Let's see what somebody else. Oh, good answers out there. Let's see what we got. Okay, let me see. We're looking for the child's weight. These answers are all wrong.
Well, we're doing 99 or 100.
We're doing 100.
Oh, okay.
Mm-hmm. Okay, the mass in number 99, the mass stays the same. Your mass is the same wherever you are. So that's going to be 60 kilograms. Then I said a child whose mass is 40 kilograms is also in the spacecraft. What is his weight there? So now, first thing you know, class, is that as the person gets further and further from the surface of the Earth, that his weight will be less because he's far from the Earth. We saw that in the last problem we did. So now you got to figure out what is his weight far from the surface of the Earth. He's at 4 Earth radii. So what is his weight? What does that mean? Well, to make sure you understand what it means, look at it like this. Okay, you have well, my pencil's not working. Okay, this is the Earth. Okay, if the person was on the Earth, that would be 1 Earth radii. Okay, 1 Earth radii, 1. And his weight would simply be mg. Now, remember we said that the weight of a person is equal to the force of gravity on that person, which is big G, mass of the person, mass of the Earth, divided by the radius of the Earth squared. Now, when the person is on the Earth, this value for G is 9.8. We solved that problem last time. So we know then that when I have 1 Earth radii, just 1, like I have here, this would give me the person's weight, which is just going to be, in this case, 40 times 9.8, whatever that is, newtons. That's on the Earth. Now, the person now is going to be another Earth radii, means his weight is getting less. Another Earth radii, his weight is getting less. Another Earth radii, that's radii, that's 2, 3, 4, and I said what? 5. I'm sorry. 1, 2, yes. He's 4 Earth radii above. In other words, class, when I put in my number here, rather than saying 1, I've got to say what? 5. And everything else remains the same. The mass of the person is the same. The mass of the earth is the same. G is the same. But now I have 5 earth radii squared. So I have to what? Square that number. So now his new weight is going to be whatever this is. Of course, this is 25. Now I have his new weight, or I should say his weight at 4 earth radii above the earth's surface. So I hope that you can remember this now, because even though at some point you may have to prove this, I want you to understand what it means. Because what you're going to find out later on in the exam, we can use a different planet. Have to be the Earth, it could be something else. But this G now is a constant. This mass is a person's constant. We'll get to that later. Okay, so I got his weight to be 15.7 newtons. That's what I got, 15.7 newtons. Okay, look at that problem again. Study your notes. In your textbook, the author goes through the derivation of G, which we did in class ourselves. Okay, let's see. I have some more problems here. Okay. All right. Now we have a muscle builder. Holds the ends of a massless rope. At the center of the rope is a 10-kilogram ball. What is the tension in the rope if the angle is 10 degrees? Okay, so now let's solve this problem. Okay, what's the tension in the rope? So what we have now is, think about it like this. The weight is going to be what? 98 newtons. How we know that? Because we're going to multiply 10 times 9.8. That's my weight. That means that that weight is being opposed by what? Some force that's acting what? Upward. Okay, that's the first thing that comes to your mind. So that means that there must be some force here that's equal to 98 newtons. And where did the 98 newtons come from? It came from the tension in this rope. So this tension now has components. It has tension along the Y, and it has tension along the X. Of course, now you can see, think about it like this. You know along the X that this is pointing in this direction, and this is pointing in this direction, and they're equal and opposite. So the sum of all the forces in X, you know, are 0, because the object is not moving left or right. In addition, the sum of all the forces in Y are also 0. So that means then that the tension that came from this side plus the tension that came from this side, which is 2 of these 2 tensions here, okay, I should say Y, I'm sorry. These 2 tensions here, this is Y, of course, this is X, and the X is equal 0, the Y is equal 0, this is acting up, and what's acting down? What's acting down then is, of course, the weight, which is 98 newtons. Okay, so now when we solve this, we find that the tension in Y is 49 newtons. That's the y part. So what that means is, I know what the y part is, but I don't know what the tension is. But because I know Pythagorean theorem, okay, I know this angle theta is 10 degrees, then I can say, okay, the sine of theta is going to be what? Opposite over hypotenuse, right? The sine of theta is opposite over hypotenuse. So in this picture right here, I can say the sine of 10 degrees is opposite t sub y over hypotenuse, which is t. So now what does that mean? That implies then that t is going to be t sub y divided by sine of 10 degrees. So what's t sub y? T sub y is 49 newtons. Sine of 10, well, I'm not sure what that is, but we can do it quickly. So I have sine of 10, and so I have 49 divide sine of 10, and I get 282. Okay, did I do that correctly? Yes, okay. So, did everybody get that answer? 49 newtons divided by the sine of 10. Okay, so I get that the tension, oops. I get that the tension right here, this tension I said is 282 newtons. That's what I got. Okay. Ooh, we have time for one more. Let's go to clear. Okay. So now I'm going to draw a picture here. Okay. So I said that the picture will be drawn on the screen. So here we go. A system of two cables. So let me see how that picture looked. Let me just give it some new numbers. Hold 1 second. Let me just give it some new numbers. It'll be the same problem with a different picture. Let me find my okay. All right, so here we go. So now I have this cable. Okay. Let me draw the. Oh no, let me find another way to do it because I can't draw the picture well. So give me just 1 minute. I still got a few minutes. Let me look at my other picture. Give me 1 second. Hold on. Okay, can y'all see that?
Yes.
Okay, so on the problem I'm giving you, I'm changing this angle to 36.9. Okay, so that's the first thing I'm doing. This angle right here, let me see, it's not 30 degrees. Okay, the angle theta is 36.9 degrees. And this weight right there is not 150. Let's see the weight. Let's just make it 200 newtons. Make it easy. 200 newtons. Okay, that's the problem I'm trying to say. This is the picture I'm trying to use, but I can't copy and paste the picture well. That's why I didn't have that picture. Okay, so now, what is the tension in the right hand cable? So of course, these are not my answers anymore. These are not. Okay, these are not my answers, of course. All right. So what is the tension in the right hand cable? So now what I'm asking you is, this is my right hand cable. It's on the right side. It's on the left side. So what is the tension in this cable right here? This is the right. So tension in the right. What is its tension? So the question I'm asking you is, first of all, think about what we just did in the other problem. That means that there must be a component here, okay, that's balancing this. So that means that there must be a component that is 200 newtons. It has to be, because that's the only thing that's bringing this down. So this component is 200 newtons, okay? And this angle I know is 36.9. The 36.9 is my 345. You recognize that. And this is my smaller side. So something times 3 gave me that answer. Okay, in other words, I can divide that by 3 and get that number. And whatever that number is, I'm going to multiply it by 5. That's how I'm going to solve that problem. So I've got 200 divide 3 and then multiply that by 5. So it should have 333. Let's see what somebody has. Oh, very good. Okay, Nigel, very good. 333, that would be newtons.
Yeah.
Okay. Mm-hmm. But you got the idea. Okay, very good. Very good. And now also you know what so this part is being balanced by this part. So that's going to be that number times what? Times 4. It's a 3, 4, 5 triangle. So now you're going to do, what is the tension in the horizontal cable, which is this cable on the left side, and you're going to have that answer. Let's see what we got here. Okay, someone said never mind. Okay, good. You figured that out. That's great. Okay, what's the tension in the horizontal cable? Okay, so you're going to have that number times 4. Okay, let's see what somebody has. What is the tension? Okay, so of course we're not thinking about these answers. This is just for the other problem. What's the tension in the horizontal cable? Anybody can give me that answer quickly? Okay, let's see who has an answer here. Okay, very good. All right. Okay. Nigel gave me a good answer. Now, if you had to work this problem through the long way, you could do that. In other words, if you had to work this problem through the long way, okay, let's do it the long way. All right, this we said is 36.9. And we know that this is 200 because the only thing opposing it in the vertical is these 200 newtons. So that means that this 200 newtons is being opposed by this 200 newtons. That's where we get the 200 from. Okay, now the question though is, what is this tension? So my right triangle is simply one that says sine of 36.9 is going to be opposite over hypotenuse. Okay, you can do that. So let's just do that first. Okay, sine of theta is opposite over hypotenuse. This means my hypotenuse then is going to be opposite divide sine of theta. My opposite is 200 newtons. My sine of theta is sine of 36.9. Okay. So we have 200 divide 36.9. 200 divide sine of 36.9. Okay. So we get 333. All right. Now, what I said though, to solve the problem even more quickly than that, what I said was recognize this as a 3, 4, 5, because the only triangle that has 36.9 as one of the angles is a 3, 4, 5. So this is my small angle. So this is some number that I multiplied by 3. This number is some number that I multiplied something by 3 to get 200. That's what I'm trying to say. In other words, 3 times something gave me 200. So whatever that number is, whatever that ratio is, I multiplied by 5 over here and 4 over here. That's quicker than doing this. That's much faster than doing all of this. So I recognize it. So I quickly say 200 divided by 3 multiplied by 5, and that's my answer. And I'll get the same answer, the 333 newtons. Down here in the horizontal, I'll say 200 divided by 3 multiplied by 4, because this is clearly a 3, 4, 5 triangle. So that's the way you want to solve it quickly. When you get to these exams and you're trying to move quickly through, and I tell you all this too, they're still discussing the exit exam. I'm not sure your discipline, what it will involve, but in some exit exams, they have simple problems like this to see if you know just how to do basic trigonometry using engineering, using biology, using whatever they're using. The same concept applies. So if you can understand this quickly, you will be so much further ahead in the game. Okay, very good. So that's all I had. So now you know that I'm going to send you an exam. The exam is like what I just did. In other words, there are no multiple choice questions. So let me go back now. I don't have it in front of me, but let me just show you this then. So let me see. Okay, when you send me your answers to the exam, you're going to say number 1. Okay, let me go back up here. Okay, so here you had a choice, right? But in the exam, you won't have a choice. For number 1, you're going to tell me 1.68 meters. Number 2, you're going to tell me 86 feet square. That's what I was saying. You have to have the units correct. That's why I was trying to stress that when you were solving the problem, you weren't giving me the correct units. So there aren't any, I've removed multiple choices, and I want you to send me back the answers like this. Hope you understand what I'm asking you. Okay. All right, very good. So the test will come to you very shortly, and you're going to send me back an answer key with your name and the answers. Now, the answers I may give a quiz, and I probably will give a quiz just to make sure that you did your own work. Just like I did this time. When I did this problem today, some of you were not getting it correct. So if I choose to do a problem again on tomorrow after the exam, I want to see you able to do your own work and to do it quickly. Okay. If we don't have any questions, then we will call it a day. Only went 5 minutes over. Please make sure if you have any questions that you can call me. If the questions aren't clear, only call me or text me if you don't understand the question. Otherwise, I'm going to post the exam, and you have until tomorrow at 1 o'clock to give me the answers. Any questions? If there are no questions, you are free to sign your name as you exit.